the steel sound like wood. During the 90s, we discovered a polymer which allowed us to laminate two pieces of steel together to create a constrained layer dampening system. Yeah, so which makes the steel sound like wood. So that's two sheets of 2mm steel with a polymer which converts resonance energy to heat. That is the purpose of the polymer. That's what it's been made for. Now that provides a 4mm thickness top plate. This is a standard 4mm steel top plate with no polymer in between.
And you can hear it ringing.
Rings like a bell.
Yeah.
Yeah. So we have acoustic steel, 4mm thickness, with a polymer designed to take resonance, to convert resonance to heat. So an energy form can neither be created or destroyed, can only be changed.
And you've got a good area here to do that. So you're not talking about some little isolating foot thing. This is a big piece of material to do a lot of conversion of that energy. So it will transfer quite a lot.
There's a lot of processes involved to produce that acoustic steel.
Back to you're talking about.
Oh, it takes huge frequencies out.
Yeah, you talk about 20 dB, or I mean, it's
and
not a little bit.
And obviously the difference between the materials. So if you have a steel version, it will take out certain frequencies.
Right.
If you have an aluminium version, it takes out a completely different frequency.
Right.
So when you merge, as we do with the quadraphonic IRAPs and tables, when you merge the two materials together to give you an intra-specific isolation, you're taking out double of the frequencies you would to the normal steel or the normal aluminium.
So it's almost. The so what about this though is when you actually do put a speaker on top of this top plate, what you're going to hear that's different is what exactly? What are you going to notice if we were to switch those plates out and we put a speaker on top and we're comparing the two? How would the sound change?
Smoother,
so
more accurate, clearer.
So it sort of hits it basically takes coloration out of the box, basically. So you're actually draining some of that energy from the box, do you think, or what do you think is contributing?
Well,
to that?
there is a balance to be had.
Yeah.
There is a balance to be had. But what you can have is a frequency can distort the sound you're actually hearing. So you only hear the high, bright sound. So if we can eliminate certain frequencies, it should produce a better sound, a more even sound, a better listening sound.
So some of this is just brain acoustics, where the way we process what we hear, the brain is going to detect certain anomalies, and then that's going to affect the whole way we hear the sound. And by eliminating some of that, you actually get a better overall sound as well. It's not just
if we can eliminate the resonance, which is the brightness sound on your music, you can actually, your brain will actually give you the illusion that the spectrum of sound is larger because you're hearing sounds which have been disguised by the brightness.
Right. So it's So that's it. You don't. Yeah. So it's masking. It's about unmasking, masking, and all those kind of effects, which are psychoacoustics as well as just actual physical.
So you're hearing the brightness, the high frequencies, and not so much the mid-range and the bass. So if we can eliminate the resonance, the frequencies occurring, which are causing the damage, it allows the mid-range and the bass frequency to be heard even better.
Right.
Hence, increasing the spectrum of the sound.